In this lesson, we're going to learn how to prove that vertical angles are congruent and also how to prove that the sum of the angles in a triangle is 180 degrees. So we're going to start with the title of our lesson today. Let me decrease the font size. Is vertical angles and triangle sum proofs. Let's start with some steps on how to prove that vertical angles are congruent. These steps are not going to make any sense until you actually see the proof. So this says begin with two pairs of angles that form a linear pair. That's what you're going to start with. Okay, so a linear pair looks like this. Let me give an example of a linear pair. Okay, so I drew an X because we're actually dealing with vertical angles. So just to refresh our brain, angle 1 and angle 3 are considered vertical angles. Angle 1 and angle 2 are a linear pair. Angle 2 and 3 are a linear pair. 3 and 4 because they form a straight line. This angle and this one put together gives me this straight line over here. Okay, so we're going to need two pairs of angles that form a linear pair. Then we're going to write two equations showing that the pairs of angles sum to 180 degrees. Okay, then we're going to use the substitution property of equality to set the equations equal to each other. So those steps might not mean very much to you right now, but we'll refer back to them in just a minute. So let's start with, the example says, use the following information to write a two-column proof showing that vertical angles are congruent. Well, unfortunately, even though we know that vertical angles are congruent, we're going to have to prove it, and we can't just say they're congruent because they are. That's not a good enough reason. Okay, so I'm going to draw this picture. Okay, 7, 8, 9, and 10, those are the angles. This is line K. This is line M. Okay, and I am going to prove that angle 7 is congruent to angle 9. Okay, and we're going to go ahead and write the word proof. Underneath that, we've got statements on the left and reasons on the right. What's great about this proof is that it's always the same. It's very predictable. Okay, so that means for you, the reasons are always the same 6 reasons in the exact same order. I think that's pretty awesome. So we'll start with the given information. Line K intersects line M. Now we can see that's true from the picture, but this is given to us. Okay, the next step is that angle 7 and angle 8 form a linear pair. Okay, and angle 8 and angle 9 form a linear pair. So let's talk for a second about how I came up with those numbers. Okay, so first, I know I'm trying to prove that 7, let me use a different color here, 7 and 9 are congruent angles. I'm trying to prove that. I need to find two pairs of angles that form a linear pair, and they have to include angle 7 and angle 9. So 7 and 8 form a linear pair. We need to also use angle 8 when we say that angle 9 and angle 8 form a linear pair. We could have used 10. Well, we would have had to say angle 7 and 10 form a linear pair, angle 9 and 10 form a linear pair. Okay, so what we've done so far is we have said that we've got two pairs of angles, 7 and 8, 8 and 9, they form a linear pair. And the reason for this is definition of linear pair. That means because they look like a linear pair, because they are a linear pair, you can see it from the picture. Okay, the next step is we're going to say that the measure of angle 7 plus the measure of angle 8 equals 180 degrees. And we're going to state that the measure of angle 8 plus the measure of angle 9, it's not very pretty, is equal to 180 degrees. Okay. And that is because angles that form a linear pair sum to 180 degrees. Okay, so what we've done so far is we have written these in equation form, and that was what we needed to do. We need equations to be able to show that these two angles are congruent. The next step is I can see that these two equations are both equal to 180. That means that they're actually equal to each other. So I'm going to rewrite this and say that they're equal to each other. Okay, so I have the measure of 7 plus the measure of 8. It's going to be equal to the measure of 8 plus the measure of 9. Okay, these are equal. Now, why did I put measure of angle 7 plus 8 on the left? Look back at what you're trying to prove. 7 is on the left, 9 is on the right. There's a reason why I did that. So what I did was I said, since both of these are equal to 180, I can say they're equal to each other. And this is the substitution property. I substituted 180 with this part. Okay, the next part is, if you didn't notice this, the measure of angle 8 is on both sides of this equation. So what I can do is I can subtract measure of angle 8 from both sides. And I'm left with the measure of angle 7 is equal to the measure of angle 9. Okay? And that was, we subtracted the measure of angle 8 from both sides. This is the subtraction property of equality. And the last step, if 7 and 9 have equal measures, the angles themselves are congruent. Angle 7 is congruent to angle 9. And the reason for that, this is the definition of congruent angles. Okay, so every time you prove that vertical angles are congruent, 1, 2, 3, 4, 5, and 6, all of these steps are exactly the same. That's really nice to know that it's that predictable, that if you're going to be expected to know this, it's going to be so very similar. The only thing that's going to change is these letters and numbers over here on the left side. All right, we have one more proof that we're going to do today, and that is to prove that the sum of the angles in a triangle is 180 degrees. So let's start with two pairs of angles that are alternate interior angles. Okay. Alternate interior angles. Now again, these steps will not make any sense until we actually do the proof. Second, state that the measure of these angles are equal. Then state that 3 of the angles sum to 180 degrees because they form a straight line. Okay. Finally, you're going to use substitution to show that the 3 angles inside the triangle sum to 180 degrees. So these are steps that always work, and that's really nice to know that those are out there. Okay. Let's go ahead and write down, we need a diagram. So this is going to take us a minute. I need to draw a line and another line. In between these two lines is a triangle like this. Okay. I'm also going to need to put some numbers and letters in my figure. Alright, so let's, right here, this is going to be angle 5. Over here is angle 7. This is angle 6. Here is angle 2. And over here is angle 3. Okay, and then the only other thing is there is point R at the top. Okay, so right here there's a point, and we're going to call it point R. Okay, with all of that, it's pretty easy for me to start my proof now. So let me increase the font size here. Okay, so I have a proof. I'm going to have statements. And I'm going to have reasons. And then why don't I go ahead, draw a line like this and one like that. Okay. All right, so we are going to prove that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees. Okay, so we're proving the measure of angle 2 plus the measure of angle 3 plus the measure of angle 6 equals 180 degrees. 2, 3, and 6 are the 3 angles inside of this triangle that add up to 180 degrees. So we're trying to prove, if you've got a triangle, all of the interior angles add up to 180. So these are the 3 interior angles. So we're going to start with, just to let you know, there are 5 steps. We're going to start with the given information. Line P is parallel to line K, and point R lies on line P. and this was given to us. Okay. On step 2, we are going to say something about the angles that are congruent to each other. And there are some alternate interior angles. So before I do anything else, I'm going to actually label that these two lines are parallel with that symbol. It's like a little arrow symbol, shows the lines are parallel. Whenever you're given information in a proof, in the given, it's nice to go ahead and label that in the picture. Okay, so with that said, now we're going to find some alternate interior angles. And I know 2 and angle 7 are alternate interior, and I know that 3 and 5 are alternate interior angles. Okay, so that means angle 2 is congruent to angle 7, and angle 3 is congruent to angle 5. Okay, and this is because alternate interior angles are congruent. Okay, so just to make sure we understand, this is the parallel lines, these two. If you pretend that this is a transversal, 7 and 2 are alternate interior. If you pretend that this is a transversal, 3 and 5 are alternate interior. Okay, step 3, we're going to state that the measure of angle 2 is equal to the measure of angle 7. And we're going to state that the measure of angle 3 is equal to the measure of angle 5. So if the angles themselves are congruent, the measures are equal. And this is a distinction that's very difficult for my students to remember. They struggle at first to understand why we have to do this. Okay. I forgot to label this as step 2. Okay, and then this is step 3. When you change the congruent symbols to be equal signs, this is called the definition of congruent angles. It's because if they're congruent, they're also equal. Their measures are equal. Okay, so now what we want to do is we want to find the 3 angles that make a straight line at the top of the picture. Angles 7 and 6 and 5. Look carefully at what you're trying to prove. It's 2 and then 3 and then 6. So that's going to matter what order you talk about these 3 at the top. So 2 and 7 are equal. So we're going to start with 7 plus the measure of angle 5 plus the measure of angle 6. Okay? So the measure of angle 7 plus the measure of angle 5 plus the measure of angle 6 equals 180 degrees. So let's look again. 7 and then 5 and then 6. Okay. And all of that equals 180 degrees. Okay. And this is, the reason for it is angles that form a straight line sum to 180 degrees. All right, there's only one more step. If you know there's only one more step, that means it's going to be just like the one at the top. Instead of 7, we're going to replace that with a 2. 5 is going to be replaced with a 3. 6 is replaced with nothing. 6 is 6. So our final answer is the measure of angle 2 plus the measure of angle 3 plus the measure of angle 6 equals 180 degrees. Okay, let me go ahead and fix that. It's supposed to be a plus sign. Okay, and the reason is we just did some substitution. This is the substitution property of equality. Okay, thank you very much for watching.